So we're moving on to dividing rational expressions. Rational means that there is a division bar. So you're dividing the top divided by the bottom. That's how I want you to think of a fraction. Like 1/2 is just 1 divided by 2. 1 is cut into 2. So when we have the rational expression, we talked about simplifying them. So factoring them, anything out that is common to the top and the bottom and canceling it. We talked about multiplying it. And now we are going to divide it, which just means when you have the two terms, you take the second term, you flip it and you multiply. Okay, that's all we're doing. But then we're going on to 6.4, which is actually truly dividing polynomials. So that's a different type of division. They just happen to follow each other. Don't get discouraged because division it looks complicated, and before you get the hang of it, it can be very discouraging. Pretty good. All right. Just make sure to mute yourself, please. All right. So rational expression, again, is just anything that has the division bar in it. Good. So we talked about multiplying as P over Q times S over R is the same as P times S or PS over Q times R or QR. Good. As long as Q is not 0, S is not 0, and R is not 0. However, when we get to dividing, what we call this is keep, flip, change. Okay. So when you're looking at, sorry, let's pick up parsley. When you're looking at your two terms, your first term, also the acronym is KFC. That's how you remember it. So the first fraction, you keep it the way it is. P over Q remains P over Q. We kept it. Okay. F means flip. So RS becomes R over S becomes S over R. That was a flip. And then you change from division to multiplication, KFC. Keep, flip, change. So P over Q divided by R over S becomes P over Q times S over R, and we know how to multiply them, right? We multiply straight across the top and the bottom. To divide by a rational expression, remember, rational just means a division. Use the rule above and multiply by its reciprocal. So when we flipped, we used the reciprocal of RS. This is just to get you familiar with math vocabulary. So the reciprocal of R over S is, you flip them, okay? S over R. So we're dividing by R over S, which means the same as multiplying by the reciprocal of R over S, or multiplying by S over R. Keep the first fraction, flip the second fraction, change the sign from a sign of division to a sign of multiplication. Okay. So we were doing multiplication to begin 6.1. We're going to do division now, but it's going to look like multiplication after we flip change it. All right. So this is x plus 3 quantity squared divided by 5 divided by 5x plus 15 over 25. Okay. So I'm going to change it from a division problem to a multiplication problem. Keep this, but I'm going to write it out more elaborately so I can see what I have. X plus 3 squared is the same as x plus 3 times itself, right? Or x plus 3 times x plus 3 over 5. So that we kept. It is the same. Flip this. So now 25 is on top. 5x plus 15 is on the bottom. Or the reciprocal, right? We multiply. If we're dividing by this, we're multiplying by the reciprocal. Keep, flip, change. So instead of division, it is now multiplication. All right. Now you can just write that again as one fraction. So that's x plus 3 times x plus 3 times 25, and I like to put the number out in front, but it doesn't matter, right? It doesn't change the value. Over 5 times 5x plus 15. Now you're looking for things to cancel, right? And noticing that my division bar was far too long. There, I don't see anything. Ooh, I do see one thing I can cancel, right? 25 and 5. I can change that to 25 is actually 5 times 5, right? And so 5 times 5 over 5. I factored 25 to 5 times 5. 5 is just 5 and 1, right? So it remains as 5. I can cancel out 2 of the 5s, and I'm left with 5 on the top, nothing on the bottom. Or another way to look at that is I just took 25 and divided it by 5, right? And I got 5 on the top, nothing on the bottom. X plus 3 times x plus 3. Here I have 5x plus 15. I'll just write it. But if I look at 5x plus 15, I can factor out a 5 from it, right? There is a 5 common to the 5x and a 5 common to the 15. 5x divided by 5 is x, and then 15 divided by 5 is 3. So I can rewrite this as 5 times x plus 3 times x plus 3 over 5 times x plus 3. The reason I did that is because now, just like the 5 and the 5 canceled, the x plus 3 and the x plus 3 cancel. And in fact, I'm left with another 5 and 5, right? And so what I have is x plus 3 over 1, right? Because there's nothing on the bottom anymore. But anything over 1 is itself. It's also okay too, before you cancel out 25 divided by 5 is 5. You can also say it's 25 x plus 3 times x plus 3 times 5, or sorry, divided by 5. 5x plus 15. I know I can factor out a 5, so 5 times 5. 5x divided by that 5 becomes, and I'll just do it right here. So I'm going to divide out a 5 just to simplify it. That 5 becomes that 5. 5x divided by 5 is x. 15 divided by 5 is 3. So now that's 5 times x plus 3 instead of 5x plus 15. If I refactor it out, 5 times x plus 3 is 5 times x is 5x. 5 times 3 is 15. So that is the same as this, right? The reason I factored it is because if I have an x plus 3 on top and an x plus 3 on the bottom as factors, I can cancel them out. That becomes 25 x plus 3 on the top. 5 times 5 is 25. And again, 25 and 25 cancel. And again, I have x plus 3 on top with nothing on the bottom. All right. So it doesn't really matter the order you go in. If you see something that you can factor out, you can factor it out. And it's a lot of math at once. I know. Factor out whatever you see, even if it's just a 2 or it's just 1x, that's okay. Okay. So what you want to do is, yes, we will do another example. Okay. What you want, and it's just like the multiplication. Okay. What you want to do is when you see something like this, put it into factored form. If you see something like this, go ahead and put it into factored form. So way up here, what I could have done is said, okay, that's in standard form. Okay, because I haven't factored anything out. And we've been factoring last unit. We did a little bit of factoring at the beginning of 6.1. Factoring is just putting it into its simplest form because you're making sure, right? You're making sure that there's nothing I can divide out of the top and the bottom. So when I look at 5x and 15 and 25, I could see that I can divide this by 5, I can divide this by 5, and I can divide this by 5. So you can start with that if you want. There are there are many ways to do this, okay? Whichever version of this you were most comfortable with, and it's okay if you were not comfortable with any of them. But 5x plus 15 over 25, I can even say that 5 divided by 25, and this is what we're going to be doing in 6.4. 5x divided by 25 is so do you see how I got from 5x plus 15 to 5 times x plus 3? I'm just changing it from a standard form to its factored form, okay? Because sometimes, not always, but sometimes when you put it in your factored form, you can then see something that you can factor out. So 5 and 25, if we were to put 25 into its factored form, maybe it's only factored form besides 25 times 1, right? So we're thinking of 25. What are numbers I can multiply together to get 25? 1 and 25, 5 and 5, right? So that would be a factored form of 25. So now that's 5 times x plus 3 over 25 becomes 5 times 5 because 1 and 25 doesn't help me, right? You can always ignore that. That's the prime factorization. It doesn't generally help. It just means I've multiplied the number itself by 1. Now I see that in these factors, I have a common factor. I can cancel out that common factor. So 5x plus 15 over 25 is actually x plus 3 over 5. So that was probably the actually. Oh my gosh. Now that I've been teaching this for 2 years, that's probably the easiest way to teach it is look at this. Make sure you can't factor this into something simpler before you start dividing. Oh my goodness. Well, thank you. Thank you for asking me to do another example so that I could better explain it the second time. Third time. That was the third time I did that one. All right. So let's talk about what we have now. Sure. Thank you for asking. Obviously. So 5x plus 15 over 25, we changed to x plus 3 over 5, right? So now we do all of this again, but with something simpler. So we don't have to worry about this part. We don't have to worry about this part. We got this into its simplest form right away because it's easier to work with smaller numbers, right? It's easier to take a 5 out of this and put this into its factored form and cancel out the 5. Then we just have x plus 3 squared over 5 divided by, instead of 5x plus 15 over 25, oh, sorry, you can't see any of that. Divided by, instead of 5x plus 15 over 25, we decided that that is x plus 3 over 5. Okay, now do the keep flip change because I can't factor, there's not going to be any common factors between x plus 3 squared and 5, right? Here I saw the common factor of, I could divide, oh, sorry, I could divide this 5, this 15, and this 25. I could divide them all by 5 and take out a 5, right? 5x divided by 5 is x. 15 divided by 5 is 3. 25 divided by 5 is 5. So that's another way to think about factoring is you're just saying, what can I divide all 3 of these terms by? And if I can do it to the top and to the bottom, I can cancel it, okay? So the simplest form of 5x plus 15 over 25 is x plus 3 over 5. Because we divided the top by 5, we divided the bottom by 5, we canceled the 5s. Good. So now we're going to keep flip change. So yesterday, or sorry, Friday, we were multiplying. You're doing the exact same thing, except before you start multiplying, you keep flip change, and then you multiply. Okay, so the factoring, this might show up in a multiplication problem. This might show up in they're just asking you to simplify it. Okay, the new skill right now for the end of 6.1 is keep flip change. Keep x plus 3 squared. So it's x plus 3 times itself. I'm just going to write it twice over 5. Flip. So the reciprocal of x plus 3 over 5 is 5 over x plus 3. Change it from a division. Now, because it's the reciprocal instead of the original, it's a multiplication. Good. I can now just write all of those in one line. So instead of, before we had 25 times x plus 3 times x plus 3, because we did not simplify it first. I did not even think of doing it. So don't feel bad when you forget to like make it easy on yourself. I forget to make it easy on myself. So now that number is just a 5 because we divided this number by 5, we divided this number by 5, and we divided this number by 5. So instead of 25 times x plus 3 times x plus 3, I just have 5 times x plus 3 times x plus 3. And I got that from there, over 5 times x plus 3. Now, because we did that work in the beginning, we changed this to this in the beginning, you can very easily see that I will be canceling the 5s, and I'll be canceling the x plus 3, and I am just left with x plus 3. Don't need parentheses. You just say x plus 3. Good. And we will do one more example of division and then kind of a word problem. So all of that to say there are some longer ways to do it, and you'll get, so that was 3 different ways to get to that same answer, depending on what you factor out and how early you factor things out. So I hope we learned that the earlier you factor it out, the better. You are welcome to do the factoring before you keep flip change or after you keep flip change. It does not matter. Okay. So we have trinomials here, right? And generally when you are factoring a trinomial, it becomes 2 binomials, right? So in the spirit of keeping things simple, let's factor everything before we keep flip change it, okay? So this one, I was trying to denote it. This one we'll put right here, okay? We have 18y squared plus 9y minus 2. Good? Okay. So what's going to happen with this guy is I need to get a whole other piece of paper. We're going to practice factoring, okay? Because here's our A, B, C, right? Because A is not 1, we're going to be factoring, we could be factoring by grouping, right? So we need it for 18y squared plus 9y minus 2. What we need is we need it to multiply to equal -2 times 18, right? What's -2 times 18? -36. It needs to multiply to equal -36. And your 2 factors need to add to equal your middle term or your b, which is 9, right? So you're going to multiply to get a negative and you're going to add to get a positive. So that means you're going to have 1 positive factor and 1 negative factor. So this is just pure factoring practice, okay? Don't think of this as anything except what you did in the last unit to practice factoring 18y squared plus 9y minus 2. All right, if you already have it, good job. I have the number 1 and 36 as my prime factors, right? Because this is a positive and this is a negative, we need 1 negative and 1 positive, and I'm always going to have my bigger number be my positive so that when I combine them, I get a positive number. So it'll be 36 minus 1 is 35. 36, I can divide it by 2, right? Because 2 times 18 was 36. So a -2 times a positive 18 will give me -36. But when I subtract them, I just get a positive 16. So that's not what I want. Can I take 36 and divide it by 3? No shame in using your calculator. You get a 12. So negative 36 divided by a negative 3 gives me a positive 12, right? If I take 12 and I subtract 3, do I get 9? Yes, I do. So remember, we're factoring by grouping. That stays as 18y squared. My positive 9y becomes negative 3y plus 12y minus 2. Good. It didn't matter if I put the 12 next to the 18 and the negative 3 next to the negative 2. That wouldn't have mattered. I did mess up my color scheme. That's what should just be inputting my two numbers. Good. So that's factoring by grouping, which we have been doing. And if you didn't do well with it in the last unit, this is opportunity to practice, and then you can retake the last exam if you want. And if not, if you have to go on to college algebra, this is going to be really helpful. So the more you've practiced factoring, the better. I know this is a lot of work for one problem, but if you take nothing from this semester, just take factoring, your factoring skills. Good. All right. So what we want to do is, let me say the word factor again. What we want to do is factor by grouping. So 18y squared and a negative 3y. I can divide them both by 3, right? And by y. So that becomes 3y, 18y squared divided by 3y. 18 divided by 3 is a 6. Y squared divided by y is a y. Negative 3y divided by 3 is just a negative 1. Good. And then we'll look at our other side. It's a positive 12y and a negative 2. The only thing I can divide it by is 2. It's a positive here, so it's going to be a positive here and here. 12y divided by 2 is 6y. Negative 2 divided by positive 2 is a negative 1. Good. So when we come back, all the way back from 18y squared plus 9y minus 2, we get the factored out 6y minus 1, because they're the same, times 3y plus 2. Okay, so all of that to say that here we have 18y squared plus 9y minus 2 becomes 6y minus 1 times 3y plus 2. Okay, let's go on. 24y squared minus 10y plus 1. Same thing. Okay, so that was the top. Now I'm going to move down to 24y squared minus 10y plus 1. Good. I'm going to need two numbers that multiply to equal a positive 24, because 24 times 1 is 24, and that add to equal a negative 10. Good. So positive 24 is going, oh, they're going to add to a negative, but multiply to a positive. So they're both going to be negatives. Negative 1, negative 24, right? But when I add them, that would be a negative 25. That doesn't help us. Yes. Thank you. Negative 6 and negative 4 become negative 10. All right, so we're keeping the 24y squared. We're keeping the 1. And that negative 10y becomes 2 negatives. Again, it doesn't matter, especially because 24 can be divided by 6 and 4. So I'm going to put the negative 6y here and then negative 4y behind it. But if you do see that, like for example, up here, well, a 2 doesn't really go with a 3, but a 3 goes with an 18. So you can put them in that order if you want to think about it a little bit, but it doesn't matter. All right. So what we get is, now we're factoring by grouping again. I want to find, hold on one second, a new note card that doesn't just have my own writing all over it. This one kind of does. All right, we have 24y squared minus 6y. Good. What can I divide them both by? I can divide them both by 3. Why? Oh, I can divide them both by 6. Look at me. Did anybody else say that before me? All right. It could be 3, but that's not going to take out all. That's not the biggest number I can factor them by. I can factor them both by 6y, in fact. So 24y squared minus 6y is going to be divided by 6y. Good. So what you're going to get is 6y, 24y squared divided by 6. Don't worry about using your calculator. 24 divided by 6 is 4. Y squared divided by y is y. Negative 6y divided by positive 6y is just going to give us a negative 1. That's okay. I've been recording it. It is not a problem. Sorry that you had an emergency. Here we have negative 4y plus 1. The most important thing to remember is that this is a negative, so it's going to be carried, okay? So whatever we're dividing them both by is going to be a negative term. 4 with a y and 1 don't have any factors except 1. But because it's minus 4y, we have to make it a negative 1. So my factor is a negative 1. Negative 4y divided by negative 1 gives me a positive 4 because a negative divided by a negative is a positive. And then a positive 1 divided by negative 1 is a negative 1. But what that should give you in the end is the same binomial to divide out. Good. So we are going to take out the 4y minus 1. And we will be left with a 6y minus 1. So either way. 4y minus 1 times 6y minus 1 is right here. We're just practicing factoring. We are just practicing factoring so far. There is nothing magical or new about this. Okay. I think that color was supposed to be that. Good. So I changed 18y squared plus 9y minus 2 to this. I changed 24y squared minus 10y plus 1 to this. It does take a lot of work, but it's work we know how to do. Okay. Moving on, we'll go on to 3y squared plus 17y plus 10. Three y squared plus 17y. Oops. Plus 10. Good. Again, check that there's nothing you can divide out. 3 and 17 and 10 don't have any common factors. We want it to multiply to equal 3 times the positive 10 is a 30. And we want it to add to equal that positive 17. So we're only going to be using positive factors now. You have 1 and 30. 1 and 30 become 31. You have 2 and 15. Ooh, that's nice. 2 and 15 becomes positive 17. We're done. Good. That's okay. All right. So 3y squared is kept. Our plus 10 is kept. And the positive 17y becomes 2 terms. It becomes a plus 2 and a plus 15. Now, if you think about this, does 3, if I wanted to factor a common factor out of it, does 3 go with 2 or does 3 go with 15 better? 3 goes with 15. So I'm going to say 3y squared plus 15y plus 2y. And if I see over here, 2y goes with the 10. Okay, it doesn't matter. You'll get the same answer in the end, but this might be, if it makes more sense to you to put them in an order that you can factor, where you see a factor, do it. Don't hesitate. All right. Okay. Factoring by grouping. So that means 3y squared plus 15y. I can divide them both by 3y, right? 3 goes into 3, 15 goes into 3. 3 goes into 15. I never know what to say. 3 goes into 15 3 times, 5 times. Yeah, sorry. I always say that backwards. I've done that a lot in this class. All right. 3y. When I take 3y squared and divide it by 3y, I just get y. When I take 15y and divide it by 3y, I get a positive 5. Okay. On the other side, I have plus 2y plus 10. So it's going to be a positive down here. 2 and 10, I can divide them both by 2. So we're going to call this plus 2. 2y divided by 2 is just y. 10 divided by 2 is 5. So y plus 5 is a factor common to both of them. So we're going to take that out. When we take out the y plus 5, we are left with 3y plus 2. Good. So over here, 3y squared plus 17y plus 10 becomes, sorry, I'm still quite sick. Y plus 5 times 3y plus 2. Did I write that correctly? Yes. All right, so that is that, and I'm color coding them just because of how many factors we have, how much work we had to do to find these, right? And finally, we have a pink, a blue. Oh, we can do yellow. 8y squared plus 18y minus 5. 8y squared plus 18y minus 5. I can't factor anything out immediately, so we need to multiply two numbers to get -5 times a +8 is going to be a -40, right? And we need to add to get a +18. Good, so we're going to make one number negative and one number positive in order to get a negative when we multiply them. And we want the bigger number to be a positive number so that when we combine them, we are left with a positive number. We're actually subtracting them and we're ending up with a positive number. So we have -1 and +40 would equal 39, right? -2, -40 divided by -2 leaves me with a +20. 20 minus 2 is a +18, and we found it. So don't worry about listing all of them if you're not checking each one as you go, because then you can stop sooner, hopefully, right? So 8y squared plus 18y minus 5 becomes 8y squared minus 5, and then that 18y becomes a -2 and a +20. I'm gonna say the 20 should go with the -5, but it doesn't matter. You know what? To show you it doesn't matter, we know that -5 and 20 have a factor of 5, right? And then 8 and -2 have a factor of 4. But what if I put the -2 and the -5 together? It'll be okay. So 8y squared plus 20y minus 2y. And we add on those y's because it was an 18y. And if I subtract 20y, or if I subtract 2y from 20y, I get that 18y back. Okay, so we're switching out an 18y. We're just splitting it into numbers we can add and subtract to get that same 18. Okay, so when I factor by grouping, 8y squared plus 20y, I can factor out a 4y, right? 8y squared divided by 4y gives me 4y. Oops. Nope, 2y, right? 4 times 4y would be 16y. 8y squared divided by 4y gives me 2y. 20y divided by 4 gives me 5. Right? Okay. And then over here, we have a negative 2y minus 5. That means I need a negative number factored out. There is no factor for 2 and 5. So I'm just going to call it a negative 1. Negative 2y divided by negative 1 gives me a positive 2y. Negative 5 divided by negative 1 gives me a positive 5. Good. But we have that common factor, 2y plus 5. 2y plus 5 times 4y minus 1. So this one is 2y plus 5 times 4y minus 1. All right, that is the work we had to do. And we knew how to do it from the last unit, right? It's still division. We're still dividing a fraction divided by another fraction, even though I didn't really write the bars in. It's still a fraction divided by another fraction, but you've done all the work. You've done all of the factoring, and you can even see as you do it, oh, I see some common factors, right? Now, what you want to do, don't forget, even though we waited, you still need to multiply this. So that means we keep the first term, flip the second term, change the sign. Okay, then you'll find even more factors, right? Once we move this up here and this down here, you'll see that, well, let's just not stop getting ahead of myself. So I'm going to keep this, right? This is a big K. 6y minus 1, 3y plus 2, 4y minus 1, 6y minus 1. And if you want, you can cancel those and just call this whole thing 3y plus 2 over 4y minus 1 if you want. Nothing wrong with that. You can cancel it right now. Okay. So that was our K. Remember, F. So that means we're going to flip this. What was yellow on the bottom is now yellow on the top. What was green on the top is now green on the bottom. Okay. So y plus 5 times 3y plus 2 is now on the bottom. Good. 2y plus 5 times 4y minus 1, which was on the bottom, is now on the top. Good. So what we have is, oh, sorry, keep, flip, change. I didn't even put a sign in between these. There's multiply, which just means straight across, right? And we decided that the 6y minus 1 has already been canceled out. It was canceled out way up here. So that becomes 3y plus 2 over 4y minus 1 times y plus 5. Sorry, that was just like I started writing too high. Times 3y plus 2. Put those in parentheses because I'm multiplying them by 2y plus 5 and 4y minus 1. So now that we've multiplied them, they are all the same. Multiplying them, yikes. Where was it? I like your little example, but it's long gone. All right. P times S is the same as PS, right? So 3y plus 2 times 2y plus 5 times 4y minus 1 is the same as putting them all in the same line. Okay. And now, just like we canceled out the 6y minus 1 over 6y minus 1, now we can cancel out 4y minus 1, 4y minus 1, 3y plus 2, 3y plus 2, and I'm left with 2y plus 5 over y plus 5. Okay. So whatever you begin, what I did here is begin with what you know how to do. I know how to factor that into two binomials. I know how to factor that into two binomials. I know how to factor that into two binomials. I know how to factor that into two binomials. I know when I'm dividing, if I want to multiply it after I did all that, if I want to change it to multiplication so that I can just look straight across, I flip or I use the reciprocal of my second fraction. So everything that was on the bottom goes to the top, everything that's on the top goes to the bottom, and then I can just cancel out my binomials. Example 8 is just substituting in a value for X if they give you a word problem. Okay, so we'll just do that quickly and then I'll let you go. Obviously, we're not going to get to 6.4, but that's okay. I'm going to take out 7.5 from this semester. So we're not, I know I always tell you this, but we're not behind. If we do get behind, that just means I cut information out of the test, right? So hopefully it's all making sense. Tell me to slow down if it doesn't, and then I just take stuff out of the test, okay? Don't be shy about telling me you need it re-explained. All right. For this ICL production company, the function C of X equals 2.6X plus 10,000 over X describes the cost per disk of pressing this number of compact discs. Not relevant today, is it? Find the cost per disk for pressing 100 compact discs or 1,000 compact discs. So the rational function describes the cost. That means that C is cost. Just if you want to feel more confident about substituting or like what you see here. The function describes the cost. So this side is cost. Good. So for A, if I have 100 disks, X is the number of compact disks. Okay, so A means it's 100. So we have 2.6. Instead of X, I'm going to put in the number 100 plus 10,000 over 100. Good. And you can, you could divide that out, right? You could cancel that. 2.6 times 100 divided by 100 is just going to be 2.6, right? And then 10,000 divided by 100 is just going to be 100. Essentially, we're dropping these two zeros, right? 100 over 1. $2.6 equals $102.60, right? Or you could put it all into your calculator. So 2.6 times 100 plus 10,000 divided by 100 gives you the same answer. So that's another opportunity to factor. 2.6 times 100 divided by 100, cancel out the 100s, you just get 2.6. 10,000 divided by 100 is 100, and then 100 divided by 100 is 1. So that cancels out. What about if you had 1,000 compact discs? So you have 2.6 times 1,000 divided by 1,000 plus 10,000 divided by 1,000. So what you can always do, and what will definitely come up in 6.4 is if you have two terms on the top and one term on the bottom, you can split them up, right? So I split this into 2.6 divided by 100 times 100 divided by 100 is 2.6. 10,000 divided by 100 is 100. So you can easily just change that to two different fractions. Okay. These are, this is what you could say is the factored form of the number. And so you can cancel out the 1,000 and then 10,000 divided by 1,000. What do you think that's going to be? 10,000 divided by 1,000 is 10, right? So that's 2.6 plus 10 is $12.60. All right. Guys, I know that was a lot, and I hope that you followed along, but good job.